Let us look at problems on areas. Let us say you throw a die. The die is equally likely to land anywhere on the sheet. What is the probability that it will land in the rectangle below?
Oh, probability. Didn't see that coming with the word area and rectangle.
Yeah, maths can be weird. I can string together multiple concepts in a problem.
Okay, so how do I find possible outcomes here?
We need to count all the possible points where the die could land. The outcomes can be found using areas here. The area of the bigger rectangle represents total possible outcomes. The area of the smaller rectangle represents favorable outcomes.
That looks simple.
Good. Let us try a problem then. You drop a die at random on the rectangular region below. What is the probability that it will land inside the square of side 1 meter? Total possible outcomes here would be equal to the grey rectangular region, which is length into breadth, or 5 meters multiplied by 3 meters, equals 15 meters square. My favorable outcomes would be represented by the yellow square region, which is equal to side square, or 1 meter square. Now the probability of the die falling in the yellow region would be equal to favorable outcomes divided by total possible outcomes, or 1 by 15. Let us look at another problem. A helicopter emergency lands in a rectangular field. If it is equally likely to land anywhere in the field, what is the probability that it will land in the circular marsh? Now the total possible outcomes here would be represented by the rectangular region, as in the previous problem. Now my rectangular region is equal to length into breadth, which is 10 multiplied by 6, or 60 kilometers square. My favorable outcomes here are represented by the circular region, or pi r square, which is 3.14 kilometers square. The probability that the helicopter lands in the marshy area would be favorable outcomes divided by total possible outcomes, or area of circle divided by area of rectangle, which is equal to 3.14 divided by 60, or 0.05. Let us look at another problem. You spin a spinning wheel. When it comes to a stop, the arrow points at one of the colors. What is the probability of the arrow pointing at the color blue?
We aren't given the radius of the circle.
Do you need to know the radius? Let us try by assuming the radius as r. Now the total possible outcomes here are represented by the area of circular region, which is a combination of the blue, red and yellow regions. So my area of circular region would be pi r square. My favorable outcomes in this case are represented by the blue circular region, which is a quarter of the circle, or a quadrant of the circle, which is equal to 1/4 of the area of circle, or pi r square divided by 4. Now the probability that the arrow lands on blue area would be equal to favorable outcomes divided by total possible outcomes, or 1 by 4. Why don't you try a problem on your own? You spin a spinning hexagon. Each side measures 1 meter. When it comes to a stop, the arrow points at one of the alphabets. If all outcomes are equally likely, what is the probability of getting an A?
This feels more like a dice problem. 3 A's, 2 B's, 1 C.
Brilliant, Ayush. Yes, you need not find any areas in this problem. Go ahead and try other problems from your textbook.
Oh yes, now I know I can ask you if I'm stuck. Thanks, Miss Al.